Welcome to EDU World Space.
So in this video, we're going to talk about question 52 from chapter 20, which asks us to compare the Lewis structures with the molecular orbital view of the bonding in NO, NO plus, and NO minus. Account for any discrepancies between the two models. So first, let's look at the Lewis structures. So for NO, we have nitrogen double bonded to oxygen. Oxygen has a full octet from the double bond and its two lone pairs of electrons, but nitrogen has just one lone pair of electrons and then a radical electron. And then we have NO plus, where removing an electron makes it more favorable to form this triple bond from moving the lone pair in oxygen into the triple bond after we remove an electron. So both nitrogen and oxygen have an octet. They have 8 electrons, 6 from their shared triple bond and 2 from their lone pairs. And then we have NO minus, where the additional electron is paired with the radical electron that we used to have on nitrogen. So let's look at the molecular orbitals for these, the molecular orbital diagrams. So how do we draw a molecular orbital diagram? Well, first we write the orbitals that are going to participate in bonding for nitrogen and oxygen. So we have our 2s and 2p orbitals for both. Of course, oxygen has one more electron than nitrogen. And we fill our 2s orbitals overlap to form one bonding sigma orbital and one anti-bonding sigma star orbitals. And then our 2p orbitals overlap to form one bonding sigma orbital, 2 bonding pi orbitals, one anti-bonding pi orbital, and one anti-bonding sigma orbital. So the sigma and pi stars are anti-bonding orbitals. So we can see we have 1, 2, 3, 4, 5, 6, 7, 8 electrons in our bonding orbitals, our bonding sigma and pi orbitals. And then we have just 3 electrons in our sigma star and pi star anti-bonding orbitals. So 8 minus 3 gives us 5, and 5 divided by 2 gives us 2.5. So the bond order predicted by this molecular orbital diagram for NO would be 2.5, which is slightly stronger than the double bond that the Lewis structure predicts. So then we can do the same thing for NO+. So the only difference in this molecular orbital diagram is that now we have one fewer electrons in our anti-bonding pi star orbitals. So remember, the electron that was in the highest energy orbital was in a pi star orbital, and now we no longer have that electron. So we still have 8 electrons in bonding orbitals, but now we have only 2 electrons in anti-bonding orbitals. So 8 minus 2 gives us 6, divided by 2 is 3. So the bond order predicted by the molecular orbital diagram is 3, which is in agreement with our Lewis structure, which has a triple bond. Finally, in NO minus, we have the exact same molecular orbital diagram, but instead of one pi star electron, we have 2 pi star electrons. We have 2 electrons in that anti-bonding pi star orbital. So we have 8 electrons in bonding sigma or pi orbitals and 4 electrons in anti-bonding sigma star or pi star orbitals. So 8 minus 4 gives us 4, and 4 divided by 2 gives us a bond order of 2, which agrees with the Lewis structure where we have a double bond.